Hey everyone, I hope you're having a great time at React Day. I know there have been a few technical hiccups, but that's okay. I mean, it's an online conference, bound to happen, right? Um, so today I'll be talking about untangling reducers into reusable patterns. So the first question is, why do we even need to talk about reducers on a React Day, right? So reducers are very handy for developers. In the React ecosystem, we encounter reducer-based state management um, quite often. It could be as primitive as use reducer that is baked within the framework, or a complete state management solution like Redux. So this talk is applicable to any complex state logic that involves multiple subvalues, especially when the next state depends on the previous one. So in the next 10 minutes, I'll be quickly sharing a bunch of ideas how you can untangle reducers into patterns that can be used across your application so that you can build your app faster. Without wasting any of the time, let's understand what is the problem we are trying to solve here. So this might look very familiar. Don't bother about reading the code. The obvious guess is that it's a long switch case, and reducers tend to grow quickly in an application. So the length increases. The more actions you put in, the more cases you need to handle. So the reducer kind of gets stretched out, right? But here, length is not just the concern here. To understand better, let's zoom in and dissect this a bit further to get more perspective. So just to be on the same plane, what is state? State is just a bunch of values that are associated together, which responds to some event. In this case, in the reducer world, it's actions. In this example, if you see, there is an enabled field that's a flag that can hold a Boolean value. And different actions can have different effect on this piece of state. So now the problem here I see is that I need to read the entire reducer just to know what all actions in the application have an impact to enable field. If I need to introduce another flag element, I have to go through each action to which it needs to respond to. So there's no central definition, and this reducer tends to become a huge giant black box, and we do not really know how it behaves. We just know that, hey, it just takes a bunch of inputs and spits out an output, right? Also, there could be transformations and derivations based on the action to deduce the new state. For example, you're initializing the state and you might set a property based on a value. Like here, enable is set true if the payload has property enable with a string value yes, right? So there's some sort of a deduction of the state based on the payload. So in a nutshell, what are the problems? There's a lot of repetitive code, right? Which quickly grows and becomes extensive and adds more risk or add more risk of error while editing. It makes it hard to extend it. Most importantly, it is difficult to identify how substate reacts to different actions. So let's take one step back and understand why did we decide this is the right way to write a reducer. To understand better, let's visit the mental model we have for a reducer right now. So in my head, I imagine reducer like a funnel. It takes two key ingredients. First is the current state. Second is the action. An action is basically an event, right? In the reducer world again. So the reducer spits out a new state. That's what we are taught in our 101s, and that's absolutely correct, right? A reducer is just a pure function that derives new state based on the current state and the action. And of course, the natural fit to solve this problem is a switch case, right? So inside the switch case, we take the action, identify its type, calculate the new state. Sometimes you need to know what the current state is. Sometimes you might not. For example, toggling a Boolean flag may require the current state, but also sometimes it can be simply extracting a value from the action object and assign it to some part of the state. So the switch control pattern solves this perfectly. And this is why we are stuck with a big black box function, right? Nobody from outside is controlling the black box or defining its behavior, at least, right? There's no behavior defined at the top level. So instead of, let's put it in this way, instead of building a funnel by yourself, let's create a constraint-based funnel. So let's assume we can create a factory that accepts a spec that defines certain behavior or patterns. And basically your factory will return a funnel instead of writing one long switch case by yourself. So something we need to note here is that the funnel is still a black box. We don't know the implementation details, but we have a definition that describes how this black box behaves. That's the difference, right? And this is called like a factory design pattern, or you can even call it a higher order reducer. So let's take the same example of enable field and create a spec for it. So let's not worry about how the factory creates the funnel for you. Let's focus on how do we describe the funnel. Right? So here is a simple config for a reducer factory you can start with for the same example which we saw earlier, right? So here, I don't want to get into implementation details here, but let's kind of read it out. So what does it communicate to us? So it says, hey, give me a field called enable, right? That's a substate value here. And basically it follows a pattern. And what is a pattern? It's a switch. So it's a switch means it can go on, it can go off, right? So we say that, okay, the switch goes on if you see an action with type enabled, and the switch goes off if you encounter an action with type disabled or clear form, right? So you can extend this configuration as well, right? Extending it becomes very simple. If you want to grab some data from payload and update the state, we can just add a new property that accepts the action, which it accepts an action, the field from the payload you need to look into. Also, you can define you can also define with any function you need to apply on that particular data before you persist it in the state, right? It can be any transformer. Like in this example, you're providing a transformer function which looks into the value and sees if it's a yes string value, right? The same way we did in the previous case. So how does this help, right? So some obvious deductions here. One is that it's very declarative. So you end up with less code to manage. It's highly extensible. You can always, add more patterns. You can extend the configuration to support more different types of behavior. It allows composition, so you are not ending up with a linear code where you need to like copy paste, and editing becomes pretty difficult. So when you're dealing with objects, composition becomes very clear. And the best part is like the state behavior is quite predictable, right? You can easily identify the substate's exposure to actions and say, hey, this state element basically responds to these set of actions, right? That is possible now. It's no more just a black box, but you have a black box with some meta information around it, right? Which you define, and that's how the funnel is controlled. So these patterns can be extended not just for switch, but it can go for toggle. Also, it can go for list, like you can append, edit, or update elements inside a list. So you can create your own custom patterns, whatever suits your use case. So naturally, the first question would be like, how do I get started? Hey, is there any tool for it? I would not like get into like suggest use this or use that, but you can always build one of these. Like it's not like rocket science. You don't need to. It's also like framework agnostic, so you don't really need to. You can reuse it across different frameworks, irrespective, because Reducer follows the same pattern. If you really want to, not get into the business of reinventing, you can look at Reducer Factory by Kubrick. We wrote that a while back, and which kind of solved most of our use cases in our applications. You can even, take some inspiration from the configuration. How can you define usable configurations? Also, if you want to get more perspective around this area, you can visit recipes in Redux official site under structuring Reducer. Redux comes up with a lot of rituals. There are ways to mitigate all those rituals and not deal with all that boilerplate. So you can have a look over there to get more inspiration as well. Okay, there. Before we kind of summarize, there's an Easter egg. So this factory, which we were talking about, doesn't necessarily need to just spit out a reducer. So you can think of, hey, I define a configuration. Maybe let me say that, hey, I have this data there's a mechanism to get this data from the server. I define where this resource is, and you can also do a lot of fun things, right? You can not just generate the reducer, but you can also give types, actions, even functions, operations, which fetch data and sets the state. Like let's say you are loading list data from the server, right? So you can do a lot of fun things over there. So quick recap. So first, we try to visit the mental model, which we have around user reducer. We try to identify the problems. The big problem was that you cannot identify the exposure of state. It's very imperative that obviously the code will grow. And the solution which we proposed is, hey, why not go with a reducer-based, a reducer factory that will allow to have a state-first reducer, and also you can test these patterns in isolation, right? You don't need to test all the time at a reducer level, but at a pattern level, and it's very declarative, right? And also we saw that these can be extended; these patterns can be extended to operations and side effects, right? So yeah, that's the end. You can ask me any follow-up questions in these sessions, or you can even post it on Twitter. I am quite active over there. So yeah, that's the